So, hi everybody. I hope you can hear me and see me. Um, I switched the slides. Welcome to today's April 2021 meetup. Um, Thank you for joining today. Um, as always, this meetup is sponsored by .NET Devs.at. We are a non-profit organization here in Austria that's about sharing knowledge in the .NET ecosystem. We have a website, we are on Twitter, we are on Twitch, as most of you are seeing, and we are on YouTube. And today is the premiere. We are streaming on both. We are streaming on Twitch and of YouTube. Had some problems in the past with Twitch, so we're streaming to both. If you have problems, if there are problems with the stream, please let me know in the chat that I can have a look at it. And we also have a Slack channel where, yeah, we are helping each other out. I'm sending you all the links to all of these sites. Would be cool if you follow us, subscribe us, depending on which platform, that you get notifications when we upload then the recordings of this session. Thanks to our sponsors. Without them, this all would not be possible. It's OGS Software and Services, Tieto Every, and Rubicon. Also thanks to JetBrains, who is sponsoring a 12 months JetBrains license for a product. We will raffle them at the end. Also, at the end there is a feedback form, and if you fill this out, you can take part in the raffle, and then we draw some lucky one and who wins this 12 months product license. Some quick news from the community. Our meetup is part of the .NET Foundation, and they have this .NET Foundation virtual user group where a lot of user groups around the world are announcing their meetups. Probably some of you found us this way. If you didn't know them yet, join this user group that you get content from all over the world. So I send you also the links to that. Additionally, more interesting. So the first one is interesting probably for most of you, or all of you geographically, is there is a Microsoft Service Ecosystem meetup here in Austria that has a meetup on June 10th about micro frontends, solution architecture and lessons learned. That's this meetup event. And then that's the one probably more only interesting for our Austrian viewers. Microsoft is still doing cloud transformation workshop for free about all different cloud topics and also the development topics. Please check them out. There are free trainings from Microsoft and SFR and remote SFR, as I know. Good, and that was it already for the intro. And now, Veronika, thanks for giving the talk today. It's about machine learning for .NET developers, and it's your stage.
Thank you, Andreas. It's really awesome to be here. I can travel virtually all over the place and be all over the world at the same time. That's exciting. So today I want to share some information for .NET developers who are interested in machine learning. So if you're just starting out with .NET or you're a seasoned .NET developer, you're using C# and F#, and you want to spice it up with some machine learning, but maybe you don't have data science degree, or maybe you do, and you want to check it out. So I think that talk will be interesting for you. Again, my name is Veronika Kolesnikova, and here, if you can see my screen, you can see my Twitter handle. So if you have any questions later, definitely feel free to reach out. Follow me on Twitter. I post some stuff here and there about machine learning and some fun stuff around Microsoft. And before we actually move to the content of the session, I want to introduce myself really quickly. I know I've never been to Austria, so probably some people don't know much about me. So I am twice Microsoft MVP in AI. I even got a cute polo shirt. I just trying to show it off. I have master's in information technology. I started my career as a quality assurance engineer, and then I moved to development. So here you can see I have more than 7 years of development experience. I think it's even more now. So I just put 7 plus, and then I stopped counting so I don't age myself. And then I used to work with mostly Microsoft technologies for most of my career up to now. I was working with C Sharp and .NET. I am really interested in Xamarin and now Maui. Check it out. I'm definitely a huge fan of machine learning. I don't have any special education in data science or machine learning, but I am really excited about machine learning, artificial intelligence, all that cool stuff. And just recently, I started working more with Node.js, React, and Java. And my hobbies are dancing, traveling, and aerial yoga. So if you have questions about my hobbies, we can talk after the session. And now let's move to the main thing, the content, because I'm sure you're all here for that. If you are just starting out with machine learning and artificial intelligence, it all sounds cool, but sometimes it might be confusion. How artificial intelligence is related to machine learning, are they connected somehow? Are they related or are they completely different things? I know some people use them interchangeably, and in some cases that's valid and that's possible. In other cases, it's a little tricky, so I wouldn't just use them randomly here and there interchangeably. But I want to explain you how they all related, and I want to start with just general definition of artificial intelligence. So in general, artificial intelligence is something that we as humans are good at, but machines are not. So developers and researchers are trying to mimic human logic and implement it in machines. So we're using if-then rules, decision trees, and some other machine learning techniques in order to actually mimic human logic. And then next here we have machine learning. Machine learning is a subset of artificial intelligence. So now you can kind of see how they related. When we have lots of data, we are trying to organize it in a way that will help not only mimic human logic in general, but also help machines to improve at tasks with experience. But in general, machine learning is a combination of statistics and logic. So the third part here is deep learning. And deep learning is a subset of machine learning. Again, when we're getting lots and lots of data, and now I think we have data about everything and anything available for us. So we want to use that data in a most efficient way and create multi-layered neural networks. And those neural networks will help the machines not only to get better at their tasks, improve with experience, but also perform more complex tasks like image recognition and speech recognition. If you heard about Microsoft Cognitive Services, All of them are based on those deep learning techniques. Um, the framework or tool that I'm going to cover today can be used for deep learning or just machine learning in general. Okay, now the most important part, I think, in machine learning. I know there's that misconception that machine learning is just that magic box that you just throw all your data there and then something magical come up and it works, it predicts, it recognizes images, and it's doing its magic. It is not actually how it works in real life. Machine learning is, I personally think, is garbage in, garbage out. So you need to think twice or many times, maybe 10 times, about the data that you actually feed in to your machine learning model and how you train it in order to create the data set and the data set which can be really useful and also efficient. It won't have any bias. You need to prepare your data before actually submitting it and trying different algorithms and creating your machine learning model out of it. You can filter your data. You can replace missing values. If you have lots of missing values, then if they are not important, then you just delete the whole. If it's a column, data is split into columns, then just delete the whole column. If it's something important, then definitely make sure that you don't have any missing information. You might need to collect more details about that before actually start training. Also, you can use normalizers. There are lots of them. I here show you just several of those. You can use min-max normalization. You can use binning. You can remove default stop words like a, is, the, and so on. So using different tools, you can access um, you can access those tools, and those tools will actually help you to clean your data, but you need to as a researcher or as a developer, you need to make sure that your data is correct, it is valid, it is up to date, and it doesn't have any bias. So it's a big thing right now with biases. Microsoft actually provided good documentation about responsible AI. So they have some standards there, some guidelines, and also some tools that can help you to make sure that your machine learning model is responsible, it is not biased, it in in the end you'll get the most efficient data model. So definitely check it out, Responsible AI. That will definitely help you with your data preparation. Okay, now we'll move finally to ML.NET itself. That's a framework for us .NET developers who want to use C# and F# to create machine learning models, work with those models. Um, as you can see here, it allows you to train, build, and shape custom machine learning models using C# and F#. And you can see the scenarios. There are just 9 of them here, but there are more and more and more available. And the team keeps working on adding new scenarios and improving those scenarios. But you can see all the main ones are covered, like sentiment analysis and object detection, sales forecasting, and so on. ML.NET is relatively new for us developers outside of Microsoft, but it was used and it is still used all around Microsoft internally for some Office tools and especially like PowerPoint and Outlook and some other tools. Um, so it is well tested. It is definitely useful. You can do a lot of things with ML.NET. It is also open source. So here you can see a link to GitHub where you can see how ML.NET works, where you can get the links to the detailed documentation. That documentation is really great there. And I won't stop repeating that. And then they also have good examples, like code samples that you can use to start working with ML.NET. So you are not starting just from scratch and randomly trying to figure out what you need to do. And here I grabbed this image from official Microsoft documentation. I hope they're not upset with me, but that is just to show you the process of building your model using ML.NET and then using the model. And I want to mention then you don't have to build your model from scratch all the time. You can reuse models created with ML.NET, or you can actually use models created with TensorFlow or Onyx. They might have support for other type of models, but I am aware of those two. But they keep working on it, they're improving it. So if you see new options coming up, that's amazing. Okay, so let's move back to that image here, the schema. You are all starting with collecting and loading your data. Assume that it's cleaned. Actually, ML.NET offers some tools, methods for you to clean up your data and prepare your data for actually building your model. But when it's all clean and prepared, you are loading it to iDataView. You are creating a pipeline using append method. And when you created your pipeline for building the model, you get that iEstimator interface that you can use for training the model using that fit method. And fit method produces iTransformer interface. You can, when you train the model, it's all set. You need to make sure that it works correctly. So you might need to improve it. There are several ways of testing the model. It usually shows what actual data scientists do. They grab one data set, they split it into two. One they use for training, and second part they use for testing, just to make sure that your model predicts or provides some kind of result that is valid, and the confidence level is high and the model is efficient altogether. If it's not, that's fine. You just need to go through the whole process again. You need to add data there, or you need to use different algorithm to create your model, so your model is more efficient. You can read more details because there are lots of different specific techniques that data scientists are using in order to improve their models. But when your model is all set, you can save your model and then use it. Usually it's saved in a zip file, so you can move it around. You can maybe store it in a container, or you can use, for example, Azure functions in order to access that model. It depends on your scenario and where you're trying to use it. One thing that I do want to mention, and it's a tricky thing, the ML.NET model is not supporting ARM. So if you are a mobile developer, if you're using Xamarin, for example, or you're a native mobile developer, then or IoT developer, Then you need to jump through some hoops in order to connect your ML.NET model with your software that you write in for mobile or IoT. As I mentioned, you can use Azure functions, you can use web apps, so it's not completely undoable, but you can't just grab your model and store it on your device and interact on your device right now. So it's been like that for maybe quite some time. Yeah, I don't want to say when exactly, but they are hoping it would be fixed with .NET 6. So let's keep our fingers crossed and hope for the best. Okay, going back to the image. I know I'm a little all over the place, but I'm trying to provide information that might be useful for your solutions. When you're ready to use the model, you just load the model using that load method. You have that iTransformer, and then using the model that you loaded, you can make predictions. Predictions like sentiment analysis or image detection or anything from those scenarios that I mentioned before. In order to make predictions, you need to create prediction engine and then call predict, and it will usually return you the prediction and then the level of confidence. So the percentage, how the model is confident that that's the correct answer. Okay, next we'll move to AutoML and ML.NET Model Builder. AutoML is not actually a specific concept for ML.NET. AutoML is a general concept for machine learning. I know Microsoft has several other tools inside Azure ML. Google has tools. Amazon has tools using AutoML. So it is not specific to ML.NET or Microsoft. AutoML helps developers and data scientists to save time because it's really time consuming to figure out the best approach, the best model that you can create out of your data using specific algorithms. So there are lots and lots of different algorithms. They're working a little differently. They are producing different models. And you need to make sure that your model is effectively using your data set and it provides really valid information. So input is correct, output is correct. So AutoML definitely saves lots of time, definitely helps us people without specific degree in data science or lots of experience. So AutoML covers the complete pipeline from the raw data set to the deployable machine learning model. You don't need to worry about a lot of stuff when you're using AutoML. But I know in lots of cases, you want to make sure that you are in control of every step. And in that case, you don't need to use AutoML. ML.NET Model Builder uses AutoML. And the Model Builder is available inside Visual Studio. It has that beautiful interface, and I'm not lying, it's actually beautiful. I'm going to show you to you during the demo. And also the CLI. I am more of a button person. I like my buttons. I like when it's all visual. But I know that lots of developers, they prefer CLI. So it's great that they have two options there. So everyone can be happy. If you're using Visual Studio 2019, then the ML.NET Model Builder is already installed. for you. You don't need to do anything. You already have access to it. And I'm going to show you in more details during the demo. If you are not using Visual Studio in 2019, then you probably need to switch because it's about time. I've heard rumors about Visual Studio 2022, so you better move to at least 2019. ML.NET Model Builder covers some scenarios, not all the scenarios available for ML.NET. But all the basic scenarios are covered, so you don't need to worry about those. And those scenarios are text classification, value prediction, image classification, recommendation, and object detection. They also have limited availability for some scenarios like anomaly detection, forecasting, and clustering, but they have really good examples of how to use those limited scenarios and also links to the documentation. So you can read about each scenario and figure out which one you actually need and how to use it. Now let's move to the demo. And while I'm switching to my Visual Studio, I want to just open the floor and check if there are any questions.
I did not yet see any question in chat, but chat, if that's your chance. No.
It's either super clear or completely not clear.
There's one question. If you can use it with WinUI.
Use what? ML.NET or the model builder?
That's, I don't know. Perhaps BB Fablis. Could you elaborate on your question? Well, either or of the two. And
Yeah.
with WinUI, you mean WinUI 3, I think.
Yeah, so unfortunately, I don't know much about it. I'm not working with WinUI. I know, as I mentioned before, it doesn't support ARM, but I'm pretty sure that Windows doesn't use it for lots of stuff. So that should be good to use with it. I'm not sure about the model builder, but ML.NET, I'm pretty sure is can be used with WinUI. Any more questions?
One that I will answer in chat.
Okay, cool. So yeah, let's move to the demo. You can see my Visual Studio open. I created completely empty console application just to show you how it all works. You can see that it is, oh, I hope it's not dying. Yeah, so that is completely empty. It is out of the box that when you create your console application, that's what you see. And how to add ML.NET model builder and how to add model to your application. So it doesn't have to be console application. I'm using the console application because it's I think the simplest one to create. But if you have a web application, even if you have IoT solution or Xamarin solution, you can still add your model using the model builder, create model, but you won't be able to use it right from your Xamarin project. Okay, so we are going to add machine learning here. Okay, and now you can see that beautiful UI that I promised you that it would be beautiful, and I think it is beautiful. Lots of information around here, links to the documentation so you can read more. Just a couple of words around it so you know what you are about to build, and those limited scenarios with examples you can also access here. We're not going to use the limited scenarios today, but I definitely encourage you to check them out and see how they are working with Model Builder. Another thing that I want to mention is those little tags, local ML and Azure ML. Local ML is using your local machine resources, and Azure ML is using Azure ML. And you can kind of guess by just looking at it that for image classification you probably need more resources, since images, they might be heavy. You might have a lot of them for your model. So in some cases you want to use Azure ML, and in some cases you're okay using local ML. So let's check this one just to see how it looks. You can still use your local environment and it will provide you the information what you have. So now you can see what I have. Um, it's okay. It depends on what kind of model you are trying to build. And then local GPU is under preview here. And then Azure, you are connecting to your Azure ML. For that, you need to create your Azure resource. I would recommend to create it before starting the model builder, but it's up to you. There are options of creating it along the way. So definitely check it out. Let's go back to the scenarios, because today I'm going to show you, I think, the most straightforward scenario, and it is text classification. It only uses local CPU. So you can again see the information about my local CPU environment. You cannot change it for this type of scenario. So whatever you have, you can't use GPU, or you can't connect to Azure if you need to. So that might be unfortunate for some scenarios, but in most cases, the text information doesn't take lots of space and doesn't need lots of compute power. So your local CPU should be enough. So we'll move to the next step to add the data. And as you can see, there are two options here to add data using a file. It should be file of specific format, CSV, TSV, or TXT. So if you have a doc file, or you have like a web page somewhere, you have to convert it to those formats. Or you can connect to SQL Server. And SQL Server should be local, or it should be connected through in your network, but it can't be the SQL instance somewhere in the cloud. For this example, I'm going to choose the file and browse it. Hopefully that's okay. So I have two options here. I was afraid that I would land in the wrong place somewhere in my personal computer, but I'm glad it didn't happen. So here I have two data sets, and those are classical data sets for testing your model, for playing with machine learning. The Wikipedia detox data sets, I have two options here, either 40,000 rows, more detailed data set, or the 250 line data set, which is way smaller. and but I'm gonna choose the one that is smaller because we don't have enough time to actually train your model for enough time to make sense of the bigger data set. So choose the smaller one here. It preloads it so you can see the content. You can see that we have the sentiment and then the sentiment text. And 1 is toxic and 0 is not toxic. It's completely fine. So you can see what kind of data you have. If you have more columns, then you'll see more columns there. And then the column to predict is going to be sentiment, because we are going to use the sentiment text in order to predict sentiment. For example, when someone submits a comment on your blog post, you can use that model to figure out if it was a toxic comment, if it was rude and you need to remove it, or it was a fine comment. So there are also advanced data options here. You can change, for example, if it's not a correct type, if it determined the type incorrectly, you can choose it here. Or you can choose to ignore it. For example, if you have huge data set with different columns that you might not need, then you can just ignore it. But we don't need it here because it's a pretty straightforward data set. And we can move to next step. So here I usually have I got lots of questions around the training time because it's really tricky. It offers you um, time based on the amount of data that you have, but sometimes that's not enough. So it is editable. And also they have that link to the article about how long you need to train your data for. Um, we can try 10 seconds because it's really quick, but I'll show you the trick in 10 seconds. So just training it here, and here you can see the output. So it checks a couple of scenarios. It didn't have enough time to actually go through several algorithms. So we just tried one, and then it, I don't know, wait, okay. Yeah, so it went through just one algorithm and shows the accuracy and then duration of training. It was just one iteration. And, the whole summary you can see here, the path for your data set, and then the label, and then the time. So when you have a bigger data set, you are training it for longer. It will have time to go through several algorithms and then pick the best one and then train your model based on the best algorithm for your data. Let's actually increase it to 20 and see if it has time to check at least another one. You can train again. I know we have a couple of, we have some time left. So I'll go through a little more extensive training. Okay. So yeah, it didn't, again, 20 wasn't enough. It went just through one model type here, and it picked that one. So it might be, in this case, it might not be directly related to the amount of time you are training it. It is most likely related to amount of data that you have, because 250 lines of data might not be enough for an efficient model but you know that accuracy is 73.05. So that is not too bad. If it's mission critical application, that is definitely on the lower side. If not, then that accuracy is not too bad. So we can move to next step, evaluate the model. I didn't split my data set into two. It was just, you need to do it before start your training, or you can have another data set for evaluation. But by default, it just shows the first um, sentiment text from the data set in order to test your model. And you just click on predict, but that is editable, so you can type whatever you want there in order to evaluate your model. So the result, it is toxic, and it's 99% sure that it is. That is good result, but because that text was used for training, I wouldn't trust it. So I would definitely, if you're building something for real, and then definitely replace this text with something that you didn't use for training. And then you're all set. You're completely agree with that model and agree with the accuracy. Then you can consume the model. You just add in it to your solution, and then you are getting two new projects in your solution. It's the model and then the console app. So the console app is just for testing to make sure that your model is actually working correctly. Um, Once you test it and you are all set with it, you can definitely remove that console app. You don't really need it. So next step, you can deploy your model right from here. You can improve your model, check how you can improve it, how you can maybe add data or increase the time for training. They have good documentation here, so definitely check it out. And then you can see the model. So that ML model.zip, that's your actual model. And then you have model input and output that you can use. The input is, let me, okay. So that's the input, your sentiment, and then sentiment text. And then the output is the prediction. It's a string. And then the score. So the score is how confident the model is that that's the right answer. Okay, and then going to that console app, you can see that it is hard-coded. It just used the first text from the dataset, but you can replace it if you want to test it more thoroughly. Then I would use just input, your client input, so you can type something in your console and then see the prediction. But it's hard-coded here doesn't mean that the prediction is hard-coded, because you can see we are consuming the model and then we are predicting based on that sample data. And then we are getting the prediction result here, and then using the prediction result, prediction here, so that will be the value. And then the score is here. So let's actually go and check the console app. And make it start a project, and then we'll just quickly run it. And you can see that's the sentiment text that we passed. The predicted sentiment value is 1, so it's root. And then the sentiment scores, it is 98%, maybe 99, 99% confident that that is a root comment. And then 0.01 of confidence that it is a pretty normal comment. So the confidence is really high. I would definitely trust the predicted sentiment value here. And then what you need to use in order to access that model. I'm glad they have that kind of demo testing console app, so you can see how you are accessing the model input. The model input comes from here, and then how you creating the prediction result. So you're not starting from scratch, even if you didn't go through the samples that they have online. It is pretty clear how to start working with it from the example. So here we need to use the model, but also the model builder here is using that Microsoft.ml. But a good thing is that if you don't remember that it is Microsoft.ml, then when you go to NuGet, let me show you. NuGet, you can just type ml.net, and you'll see that Microsoft.ml. So that's the one that you need in your project in order to work with ml.net. So Microsoft.ml and Microsoft.ml.data. And then you also need to connect to that model project. And then you are actually, going through. So yeah, I think I'm a little all over the place because the program is actually for testing. The model builder file shows you what the model builder actually did. So I grabbed your file, and then it loaded it, and then it built the training pipeline. So the same schema that I showed you is kind of showing here, um, not in a schema, but in a code shape. You can see how it went through some evaluation and transformation, and then it saved the model, and then you got that mlmodel.zip file. So that's that. I wanted to show you the CLI part, but I don't think we have enough time for that. If you want to go through the CLI that the path, then it is pretty similar. You just don't have those pretty buttons that I personally love a lot. You are basically installing MLNet tool using .NET command, and then you are working with MLNet right from your CLI. So I want to check if we have any questions.
There was one, but the chat already answered that. It was
Okay.
about how you get to the ML Builder UI. Okay, can you show again the NuGet package? The
Oh yeah, sure.
Someone is
Yeah.
asking for the name of the package.
So you're going to NuGet, and then if you don't remember the actual name of the package, you just type ml.net. And you'll see that first one, Microsoft.ml. And then you might need also Microsoft.ml.data. And you can see there are several of them. So if you're working with TensorFlow model, then you probably need the TensorFlow one. If you're working with Onyx, then you probably need that Onyx transformer. Um, but the main one is definitely that Microsoft.ml.
Good, cool. Any other questions, chat? Now you have the chance.
I wanted to show this slide again so people can see my Twitter handle in case they have questions later on. Feel free to reach out. You can find me on LinkedIn, but please, please, please write something how you know me and why you're trying to reach out, because there are lots of spam going on in LinkedIn.
There's now one question. Do you know if it's possible to use ML.NET for statistical inference as well?
I'm pretty sure you can. I've never done it myself, so I'm not 100% positive. But I read that I think some people tried to do it.
Good. Good. So then, yeah. Thanks from Gregor for answering that. Good. Then we are at the end. Veronika, thank you uh,
Thank you.
for being here today. Thank you all for joining today's meetup. Um, I also have to thank our sponsors, OGS Software Services, Tieto Every and Rubicon, and JetBrains for the license. To that in more detail shortly. If your company or you want to sponsor us, talk with us. We have some information on our websites about sponsoring, but that's yeah, suggestions. We are happy to talk with you. Um, Next meetups, we have some cool topics lined up for the future. So already announced is the one for the May 11th. It's about asynchronous background processing in .NET with Hangfire from Fabian. Fabian. In June, we will have our after conference talk show of the Microsoft Build Conference. And in July, we have a talk by Brandon Minnick about Maui, .NET Maui. Looking forward to all of this. Hope I see you there also. If you want to see a topic at our meetups, we have a GitHub issue, GitHub repository, where you can create issues to request topics. So if something is missing, you want to know something, uh, please add there an issue, and we are looking for a speaker. Yeah. Also, please spread the word that we are doing these meetups. We have monthly meetups. We try to have every month a talk, an interesting talk for you. I think we are on a 3 years run now. Invite your colleagues, invite your friends, customers, retweet our stuff, invite anybody, everybody that you know that has something to do with .NET to our meetups. Um, Again, we are available on various platforms. Quickly the links again to all of you. Recording will go up in the next days on YouTube of this. And yeah, the last one. We want to improve these meetups, and for that we need your feedback. We have a short feedback form prepared. If you could fill this out, it would be wonderful. And there you have also the chance to then take part in the raffle of the JetBrains license. And yeah, would be cool if you fill this out. It takes only 2-3 minutes and helps us for the future. And I forgot something. Veronika, every one of our speakers gets a custom made coaster with our logo.
Oh,
So I will
wow. That's exciting.
get in touch with you how I get it to you. Hope Postal Services delivers to you at the moment.
Thank you.
Good. Yeah, thank you again, Veronika, for being here today. And I hope uh, I see all of you on May 11th, the next time for the next meetup. Bye.